Hello again, Community Middle School. This is part 2 of our eclipse talk in preparation for the partial eclipse coming up on April 8th. One of the questions that I've had is, if the moon is so much smaller than the sun, how does it appear to fit perfectly over it? If I show you, let's see if I can do this. Yep. If I show you this picture here, it looks like they're exactly the same size. And we know that the moon is much smaller than Earth. And we know that the sun is much bigger than Earth. So what's the deal with that? Well, in actuality, the sun is about 400 times bigger, just in diameter, not volume, but in diameter, it's about 400 times bigger than the moon. So, let's see if I got this in my pocket. I found a little tiny BB that I use for some of my physics lessons. Okay, this teeny tiny little BB is about the right size if I scale the sun down to a diameter of 2 meters. So let's walk over here. I have made a sun for you that's 2 meters in diameter. Okay, so this teeny tiny little BB compared to this sun is moving in front of the sun, and it's covering it up completely. The cool thing is about our solar system setup is that the sun is 400 times bigger than the moon, but the moon is 400 times closer to Earth than the sun is. And so it works out perfectly for it to look exactly the same size. We've got this, the mechanics of our solar system are such that this happens, this lines up just perfectly every once in a while. It doesn't happen very often. And one of the reasons for that is, turn my sun back on here. My sun is just a light bulb, and this is not to scale, just so you know. See if you can see the sun. Okay, so this is the sun, this would be the moon, and this would be the Earth. And remember, when we're seeing this solar eclipse, the moon is revolving around us counterclockwise, and it comes in between us and the sun. Well, if we're here on Earth and we're seeing this at nighttime, we would not see any of the moon illuminated because we're looking at this side of the moon, right? And that is called a new moon. It's in the new moon phase. If we continue moving around, revolving around the Earth, we get to the quarter phase, we get to the full moon phase, and over here, this is where we actually would get a lunar eclipse. And then back around to the new moon phase. Well, then why is it that we don't get a solar eclipse or a lunar eclipse every month? We know we get a full moon every month, at least one. We know we get a new moon every month, at least one. Well, it turns out that the moon's orbit is tilted just slightly to Earth's. And so it's not very often that it lines up so perfectly. And this is one of those really cool times where it does. And again, the moon is so much closer to us, it makes it look the same size as the sun. Perfectly the same size. Really, really cool. Another thing I wanted to talk about today is the path of totality. If we look at this map right here, you can see that the path of totality is right here, and it's a pretty skinny little area. That's going to go all the way across from Mexico. It's going to come up through Texas, move across the United States, and then out through Maine, out to the ocean. Indiana is somewhere in here, and that's where I'll be on the 8th. But if you look a little bit north of here, you can see that in, like in Iowa, they're going to be able to see 80% of the sun covered. Us here in Little Falls, we're going to see somewhere around 70-75% of the sun covered. And the further you go north, the less and less. Like way up here in Canada, they're only going to see just a little bite mark taken out of the sun. And same thing way down here by Cuba. The path of totality, usually, if you look at the history of solar eclipses, usually that goes right over the ocean. And so very few people will see a total solar eclipse aside from the few solar eclipse chasers that are out there. Usually scientists that are studying the sun for one reason or another. One of the things that we're able to see during a solar eclipse is the atmosphere of the sun. It's called the corona of the sun. And we can see some solar flares, and we can do some studies on the sun during these moments that we can't do at any other time. And so scientists are really interested in hitting a lot of these locations whenever a total solar eclipse happens. We did have one here that went across the United States in 2017. You might remember that. It was in August of 2017. Here in Little Falls, it was a partial eclipse. But down in Missouri, it actually came in from Oregon and went out through the Carolinas. So I went down to Missouri, Jefferson City, Missouri, and I was able to see the total solar eclipse. And in our next segment, I will be talking about that experience and showing you some pictures of some of the different tools that people made or bought to look at the solar eclipse safely. And I'll also show you how to make something called a pinhole viewer. And for that, folks, just so you know, you'll need an empty cereal box. So if you have cereal at your house, save one of those boxes, and then you also can make a pinhole viewer with me. Just another way to view it. All right, until next time,